Ever get that feeling? Like when you spot a friend in a crowded room, you know that feeling like your brain is making these intuitive leaps, these connections that a computer just wouldn't get.
Yeah, definitely.
Well, we're going on a deep dive today into some research that's trying to bridge that gap using quantum physics, believe it or not.
It really is fascinating, trying to bring together these two fields that seem worlds apart, quantum physics and machine learning.
Yeah.
But when you think about it, the bridge is kind of the human brain itself.
Okay, so let's unpack this. We're looking at a research paper with a pretty dense title. Quantum-probabilistic Hamiltonian learning for generative modeling and anomaly detection.
Yeah, that's a mouthful.
Help us out here. What's the need to know in plain English?
Basically, this paper is all about how we can use these principles from quantum mechanics to analyze data in a completely new way. So imagine a computer that doesn't just crunch numbers, but it can actually deal with uncertainty and make these intuitive leaps, much like our brains can.
So instead of just ones and zeros, it's like we're teaching computers to think in shades of maybe.
Exactly. That's a great way to put it.
Yeah.
And the key to all of this is something called the Hamiltonian,
Okay.
which is a core concept in quantum physics.
Yeah.
And you can think of it like the rule book for how a quantum system changes over time.
Okay, I'm following so far. But how does this Hamiltonian thing connect to something like my brain recognizing someone's face?
Now think about it. Our brains don't operate on perfect, crystal clear information, right?
Right.
We're constantly dealing with this flood of input from all our senses, and yet we can still pick out a familiar face in a crowd.
Yeah.
Quantum systems are kind of similar. They exist in these blurry states of possibility,
Right.
what we call superposition in quantum physics.
Right, like that whole Schrodinger's cat thing, where
Yeah.
the cat is both alive and dead until we look.
Precisely. And what these researchers did was they represented data as a quantum mixed state,
Okay.
which is kind of like saying that the data exists as this blend of multiple possibilities. And this actually mimics the uncertainty that we see in both quantum mechanics and in how our brains process information.
So instead of a computer seeing things as black or white, we're teaching it to embrace the gray areas, the maybes.
Exactly. And by doing so, they found that they could train a system to not only recognize patterns, but also to pick out anomalies, those things that stand out as unusual or unexpected.
That's fascinating. It's like our brains are doing quantum calculations all the time
Yeah.
without us even realizing it. But how did the researchers actually put this theory into practice? What do they test this on?
They decided to test it on data from the Large Hadron Collider,
Okay.
the world's largest particle accelerator.
Okay, we're talking about smashing particles together
Yeah.
at nearly the speed of light.
Mhm.
How does quantum-inspired machine learning even come into play there?
So when you smash these particles together,
Right.
you get this shower of other particles. And physicists are trying to find specific patterns in all that data. The researchers wanted to see if their quantum-inspired system could accurately identify the signatures of a very specific particle, the top quark.
Right. I remember you mentioning top quarks earlier.
Yeah.
You said they were important, but why? What makes them so special in the world of particle physics?
Well, for one thing, they're the heaviest of all the known fundamental particles.
Huh.
They're like the sumo wrestlers of the quantum world.
Okay.
But what makes them really interesting is that they decay very quickly, making them extremely difficult to detect and study.
So it's like trying to find a needle in a haystack while the haystack is on fire. What did the researchers find when they set their quantum-inspired system loose on this top quark mystery?
Well, this is where it gets really exciting. The system was actually able to sift through these massive amounts of data from the Large Hadron Collider and pick out the collisions that produce top quarks
Wow.
with remarkable accuracy. Essentially, they created a system that could filter out all the noise and pinpoint the signals they were looking for.
Wow, that's impressive. So they've essentially given particle physicists a much sharper tool to study the universe's fundamental building blocks.
Yeah.
But you said earlier that this has implications beyond just particle physics, right? What's the bigger picture here?
Well, think about it. We're talking about the ability to detect these subtle patterns and anomalies
Yeah.
in incredibly complex data sets.
Right.
Now imagine applying that to other fields, like healthcare.
You mean like using this to analyze medical images and
Yeah.
potentially diagnose diseases earlier and more accurately?
Exactly. This could be revolutionary in fields like radiology, where spotting tiny tumors or irregularities in scans can be a matter of life and death.
That's incredible. It seems like the possibilities are almost endless. Are there any other areas where this kind of technology could have a major impact?
Absolutely. Think about finance. This technology could be used to detect fraudulent transactions or identify patterns in market data. That would be invisible to traditional algorithms. It could even be used to improve weather forecasting or develop more effective climate models.
This is starting to sound like something straight out of science fiction, but before we get too carried away, are there any limitations to this technology? I mean, simulating quantum systems sounds incredibly complex and computationally expensive.
You're right to be cautious. This is still very early stage research,
No.
and it faces some significant challenges. One of the biggest hurdles is the sheer computing power needed to simulate large quantum systems. Right now, it's like trying to run a marathon on a treadmill. That's only capable of a light jog.
So we need bigger, faster, more powerful computers to really unlock the full potential of this quantum-inspired future. But what about the theoretical implications? How does this research change how we think about the nature of data itself? It's like we're blurring the lines between physics and computer science and even neuroscience.
Yeah, it really is fascinating.
If we can teach computers to think more like our brains, using quantum mechanics, what does that even mean for the future of intelligence, both human and artificial?
That's a huge question.
Yeah.
And what we're really talking about here is like a potential paradigm shift in how we understand data itself.
Okay.
Right now, we think of data as these like discrete bits of information, ones and zeros. Right, but what if data, at its most fundamental level, operates more like a quantum system, full of probabilities and uncertainties?
So instead of trying to force data into these neat little boxes,
Yeah,
we should be embracing its inherent fuzziness, its quantum nature.
exactly. And by doing so, we might unlock these algorithms that are not just like faster or more efficient, but fundamentally different in how they approach problem solving. Imagine algorithms that are more creative, more adaptable, more capable of making those intuitive leaps that we currently associate with human intelligence.
This is blowing my mind here. It's like we're on the verge of this whole new era of computing, one that's less about brute force calculation and more about harnessing the power of quantum uncertainty.
And here's another fascinating angle to consider. You know how there's this ongoing debate about whether our brains themselves utilize quantum effects?
Yeah, I've heard about that. It's a little out there.
It's pretty out there.
But if it's true, that would mean our brains are basically quantum computers.
Well, some physicists are taking that idea very seriously.
Wow.
And if it turns out to be true, then these quantum-inspired algorithms we've been discussing, they might not just be mimicking our brains, they might actually be tapping into the same fundamental principles that govern our own thoughts and consciousness.
Okay, now my head is really spinning. This has been an incredible deep dive. We've gone from particle collisions to the very nature of intelligence all in one episode. But before we wrap things up, any final thoughts for our listeners? Something to ponder as they go about their day.
Here's something to chew on. If we do manage to develop these truly quantum-inspired algorithms that can think more like us, will they help us unlock even deeper levels of human cognition? Will we learn more about ourselves by building machines in our own image, so to speak?
Wow, that's a profound thought. It makes you wonder if we're not just on the cusp of a technological revolution, but a revolution in self-understanding as well. And on that note, we'll leave you to ponder the possibilities. If you're interested in diving deeper into this research, check out the show notes for links and additional resources. Until next time, keep those brains buzzing.
And remember, sometimes the most mind-blowing discoveries happen at the intersection of seemingly unrelated fields.